elements. General periodic properties you would have studied in 10th standard itself, so we will quickly rush through those topics. The atomic properties is atomic radii increases down the group, covalent and ionic radii also increases down the group. They may not ask you the reason. Sometimes if they ask you a test, in any of the test, if they ask you the reason, we have to give this increase in the atomic number, addition of new shell or inert pair effect, you can say. Ionization enthalpy in general, it decreases down the group. And two points regarding ionization enthalpy you have to remember. One, it decreases down the group. Second one is, first ionization enthalpy of any element will always be smaller than the second and third. That you have to remove. This is due to the reason that once one electron is removed from the atom, it will attain either an inert gas configuration or it will have a stable fully filled or half filled orbitals. Therefore, it will be difficult to remove the electrons. Therefore, the second and third ionization enthalpy will be generally high for any element in the periodic table, not only in P block. Okay, and electronegativity also, you know that electronegativity, if you see, it increases from left to right in the periodic table and decreases from top to bottom in the periodic table. Other physical properties like metallic character. In the previous class I told you the trend in the P block is not very smooth. I told you that the linear is not a linear trend. What does it mean? Metallic character, if you take metallic character, you can say generally it increases down the group. That is, the top elements will be non-metals. The first two elements in any group of periodic table will be generally non-metals. If you take nitrogen group, NPOS and B, nitrogen and phosphorus will be non-metals. Similarly, OSA, TEPO, if you take oxygen and sulfur will be non-metals. Similarly, if you take fluclobroid, in there you can see all of them will be non-metals. Fluorine, chlorine, bromine, iodine, all of them will be non-metals. Okay, so that's what I told you. The trend in the is in the periodicity of the P block elements is not linear. There will be some fluctuations in that. Okay, so the first two elements is generally non-metallic in nature, and the next two elements will be generally metalloid in nature, and the last one will be metal in nature. This will vary from group to group. In general, metallic character increases down the group. Okay, as a corollary point to this property is, you know that non-metallic oxides, if you take the non-metallic oxides, do you remember how they will behave? Non-metallic oxides will be acidic in nature. Metallic oxides will be basic in nature. So by remembering this metallic character, you can also answer this question. That is, if you look at the oxides of nitrogen, they are acidic in nature. If you look at the oxides of bismuth, they will be basic in nature. How will you identify that? I have told you in the some of my previous classes. If you take NO2, if you take NO2, if you add water, what you will get? You will get HNO3 plus HNO2. That is, if you add these two, you will get H2N2O5. That is written like this, two acids. Therefore, it is acidic. If you take, say, bismuth oxide, okay, Bi2O. If you add water, then it will form hydroxide. So it will be basic in nature. So by remembering the metallic character, you can predict the acidic property of the oxides also. So that point you have to remember whenever you think of metallic character. Then melting point and boiling point. Again, you can see that the melting point will increase from nitrogen to arsenic. Because you know nitrogen is a gas, phosphorus is a non-metal, and arsenic is a metalloid. the melting point generally increases in the group, but if you see from antimony and bismuth, it decreases. Suddenly it decreases. Bismuth will have less melting point comparative to arsenic or antimony, and this is due to inert pair effect. The intermolecular force, the interatomic forces decrease. Although the size of the atom is high, due to this inert pair effect, the interatomic forces decreases, therefore the melting point decreases. So these type of anomalous behavior you have to remember, because this is what generally they ask you in the exam. Because as I told you, the trend is not smooth. It's not just to go linearly like that. There will be sudden change will be here. And if you take the boiling point again, boiling point has got a general trend. That is, it increases from top to bottom. Down the group, it increases due to increase in the size of the atom. Therefore, the attraction between the two atoms increases due to surface area. Therefore, boiling point increases. Here, there is no hydrogen bond or something like that. Okay, it's only the metal, the element that we are talking here. And similarly, if you see the density, see these properties, no, sometimes it will confuse you. You have to be careful. When you say the density increases down the group, naturally the melting point should increase down the group, but there is a slight variation here. That is why this has to be, I have highlighted that, you remember that point. Density increases, boiling point increases, whereas melting point is not smooth. And the last property is the allotropy. You know what is allotropy? Allotropy is the tendency of an element to, that is different forms of same element. Different forms of same element. That is, they have their physical properties will be different and the chemical properties will be different, but their atomic number will be same. It will not be different. It is different from isotope. Allotropes are different from isotopes. That you have to remember. Nitrogen and bismuth does not form any allotrope, whereas phosphorus, arsenic and antimony forms allotropes. Okay, then we will go to chemical properties. Chemical properties, first we will see the oxidation state. This is very important because in all the P block related questions, you have to remember the common oxidation states of all the elements. Then only you will be able to predict the products. We will be doing it now. We will see that now. So generally there are two types of oxidation states. One will be negative, another will be positive. Okay, nitrogen will form a 3- trivalent anion, divalent anion and monovalent anion. So as I told you, because of the anomalous behavior, the first element, nitrogen or the behavior வந்து ரொம்ப யூனிக்காக இருக்கும். அது நிறைய ஆக்சிடேஷன் ஸ்டேட் அது ஃபார்ம் பண்ணும். அது நெகட்டிவும் நிறைய ஃபார்ம் பண்ணும், பாசிட்டிவும் நிறைய ஃபார்ம் பண்ணும். யூ கேன் see that here. I have given you the list starting from ammonia. இது நீ ஆல்டிஹைட் சாப்டரில் படிச்சிருக்கா. ஹைட்ராசீன் அப்படின்னு பேர், இதுக்கு பேர் ஹைட்ராக்சிலமீன், நைட்ரஜன் எலமெண்ட், nitrous oxide, nitric oxide, nitrogen trioxide, nitrogen tetroxide, nitrogen pentoxide. பேர் இல்லாமல் நீங்கள் ஞாபகம் வச்சுக்கணும். ஆக்சைட்ஸுக்கு வரும்போது நான் தனியாக திருப்பி சொல்லி கொடுக்குறேன். So you should remember the names of all the oxides, and you can see starting from -3 to +5 range of oxidation state is there, and in the compound alone you should be able to identify it. These are all called as nitrides, phosphide, ide salt in pair. They are all called as ide salt. So what are ide salts? Ide salts are anion of the P block elements. Fluoride, chloride, oxide, bromide, iodide, carbide, nitride, phosphide, arsenide, bismuthide, stilbide. அந்த எலமெண்ட் பேரை போட்டு பக்கத்தில் ஐடுன்னு போட்டுக்கணும், அவ்வளோதான். அதை போட்டுட்டேன்னா அந்த காம்பவுண்டு பேர் உனக்கு தெரிஞ்சிடும். நான் எதுக்காக இதை சொல்கிறேன் அப்படின்னா, நீ இந்த மாதிரி ஏதாவது கொஷின் எழுதும்போது இந்த காம்பவுண்டு எழுத வேண்டி உனக்கு வந்ததுன்னு சொன்னால், நீ அதை சென்டென்ஸில் எழுதுனேன்னா இன்னும் கொஞ்சம் நல்லா இருக்கும். அது அதாவது மெக்னீஷியம் நைட்ரைடு அப்படின்னு நீ எழுதி, கால்சியம் பாஸ்பைடு, சோடியம் ஆர்சனைடு, ஜிங்க் ஸ்டில்பைடு, மெக்னீஷியம் பிஸ்மத்தைடுன்னு நீ வேர்ட்ஸில் எழுதி எக்ஸ்பிளனேஷன் எழுதுனேன்னு சொன்னா கொஞ்சம் இம்ப்ரெசிவாக இருக்கும் ஆன்சர். அது யூ கெட் அ பெட்டர் சான்ஸ் ஆஃப் கெட்டிங் மோர் மார்க்ஸ் ஃபார் தட் கொஸ்டின். Okay, so you should know the names of that. And we have already seen that LOS stability and HOS stability due to inert pair effect. And because of the inert pair effect, we know that N plus 3 is least stable and N plus 5 is most stable. Similarly, BI plus 3 is most stable, BI plus 5 is least stable. Okay. In that, this is another point that you have to remember. A large amount of energy is needed to lose all 5 electrons due to inert pair effect. Now, the screen I showed you, tellurium, if you want to remove the 6s2 electrons, you have to, it is shielded by the 5d10 and 4f14, which has got a poor shielding effect. Therefore, it is strongly held by the nucleus. Therefore, you need more energy to remove that electron and sunnelia. Large amount of energy is needed to lose all the 5 electrons. Nitrogen இருக்கிற அந்த 1s2 2s2 2p1 2p3 இருக்கும்போது அந்த 2s2 ரிமூவ் பண்றது வந்து கஷ்டமா இருக்கும் அந்த இடத்துல. Therefore, when we compare to that, so some extra energy is supplied, has to be supplied to remove those 2 electrons in the s orbital, ns2 orbital. Therefore, whenever you supply more energy, the M plus ions cannot be formed, or with very great difficulty they will be formed here. And therefore, pentavalent compounds are covalent in nature. If you take PCl5, PF5, SBF5, BIF5, they will be covalent in nature. Why they are covalent in nature? Whenever a compound requires very high energy for the formation, then it will be generally covalent in nature. Because if you want to compare, when you want to compare, say, sodium, formation of sodium chloride, you will know it better. Sodium it will easily form Na plus, no difficulty. It attains the stability, octet stability. Similarly, chlorine will take that electron to attain the octet stability, no problem. It is very easy. Formation of Na plus and formation of Cl minus is very easy. Therefore, whenever 2 ions are formed very easily, generally they form ionic compounds. Okay, and vice versa. Whenever an element is formed, ions are formed with difficulty, then you will have covalent compound type of formation. This is a general rule. There are exceptions. Okay, so and the covalent character of the compounds generally decreases down the group. Because N plus 5 is most stable, no, and Bi plus 5 is least stable. Therefore, which one, எந்த element plus 5 நல்லா form பண்றதோ or more covalent இருக்கும், எந்த element plus 5 state கம்மியா form பண்றதோ அது less covalent இருக்கும் or more ionic இருக்கும். அது அந்த மாதிரி நீ புரிஞ்சுக்கலாம். Or you can also remember like this: metals generally they try to form ionic when compared to non-metals. Okay, so that is the point that you have to remember regarding the oxidation state. You should remember what are all the different oxidation states of the nitrogen and other elements, common oxidation states. Why you have to remember the common oxidation state? Because whenever you want to predict the product of any reaction in involving those elements, you should know and the compound and the element in the oxidation state என்னவா இருக்குன்றது உங்களுக்கு தெரியணும். ஸோ அது தெரிஞ்சாதான் அந்த ஆக்சிடேஷன் ஸ்டேட்ல அந்த காம்பவுண்ட் ஃபார்ம் ஆகுன்றது உனக்கு தெரியணும். ஸோ இப்போ அந்த எலிமெண்ட் வந்து அந்த ஆக்சிடேஷன் ஸ்டேட்ல எக்ஸிஸ்ட் ஆகலைன்னா நீ அந்த காம்பவுண்டு எழுத முடியாது. ஸோ தட் இஸ் த ரீசன் யூ ஹாவ் டு ரிமெம்பர் தி காமன் ஆக்சிடேஷன் ஸ்டேட்ஸ் ஆஃப் எலிமெண்ட். தட் யூ வில் ரிமெம்பர் only by practice. Okay, and then maximum covalency பார்த்தேன்னா nitrogen will have a tetravalent because 3 வந்து normal valency, 4th lone pair அது கொடுத்ததுன்னு சொன்னா it have a tendency to form a cation, like this, in which it will donate a pair of electrons to the 4th atom and forming a coordinate bond. Therefore, it can show a maximum of tetravalency. So this compound, if you see ammonium chloride, this will have 2 types of bonds. It will have both covalent bond as well as ionic bond. Covalent bond and ionic bond. Covalent bond and ionic bond. Covalent bond is present in NH4. All the NH4 bonds are all covalent bonds. NH4 plus and Cl minus have got ionic bond. This compound is little unique when compared to the other compounds. Okay. Sometimes you may get a crazy question in your class test or quarterly, half-yearly. Name a nitrogen compound which has both ionic and covalent bonds. And the mother you can get a question. So you should know that this is the maximum covalency for nitrogen. Why nitrogen cannot show pentavalency? Because it does not have the d orbitals. I told you, whenever you get any question regarding the first element of the P block, immediately you have to mention about the anomalous behavior. And in that anomalous behavior, you should remember what aspect is will be related to that. So in the formation of, in the question, pentavalent, why it doesn't form? It is due to the absence of d orbital that you have to remember. Other compounds easily form pentavalent state. So PCl5, ASF5, PF6 minus, SF6 minus, etc. Okay. Then disproportionation. Now this is a very, very important concept. இதை வச்சு தான் நம்ம பி பிளாக்ல இருக்கக்கூடிய எல்லா ஈக்குவேஷனுடைய ப்ராடக்ட்ஸ் எல்லாத்தையும் நம்ம ஈஸியாக ப்ரெடிக்ட் பண்ணுறதுக்கு சௌகரியமாக இருக்கும். அது இது நல்லா கவனமாக பார்த்துக்கோ. இதை நீ ஏற்கனவே படிச்சிருப்பேன். யூனோ வாட் இஸ் டிஸ்ப்ரொபோர்ஷனேஷன்? ஒரு காம்பவுண்டில் இருக்கிற ஒரு ஆட்டம் வந்து அதுவும் the same atom will undergo both oxidation and reduction. That is called as disproportionation. Generally, highest oxidation state இருக்கக்கூடிய elements வந்து they do not show disproportionation. Why? Because already they have lost all the electrons. They cannot lose any more electrons. They can only gain electrons. That means they cannot show disproportionation. Disproportionation means it has to show both oxidation as well as reduction. Then only you know that disproportionation. So, எந்த type of compound disproportionation பண்ணோம் அப்படின்னு சொன்னா, generally, whenever an element is existing in an oxidation state, intermediate between the lowest and the highest. Now we will see what is lowest and highest. It is different from LOS and HOS. I will tell you what it is. Suppose if we take nitrogen, you have five valence electrons you have. Okay, 5 valence electrons you have. Now it can gain 3 electron. It can gain 3 electron to become N3 minus to attain octet, or it can lose 5 electrons to become N5 plus. Okay, therefore now if you look at this, the lowest oxidation state of nitrogen is -3 and the highest oxidation state of nitrogen is +5. Nalla paathuko, this is different from LOS and HOS. This applies for any element. For example, if you take oxygen is 2,6, right? That means it can gain 2 electron. It can gain 2 electron and become O2 minus. Therefore, lowest oxidation state will be +2, and it can lose 6 electron. Therefore, it can become +6. It can attain +6. So the lowest and the highest. This is lowest and this is highest. So this applies for any element in the periodic table. That is the lowest oxidation state and the highest oxidation state. So that is why when we studied yesterday about LOS and HOS, we should not use the term lowest. We should say lower oxidation state and higher oxidation state. Okay, it's not lowest or highest. Similarly, this is lowest and this is highest. So this you should remember. Why we should remember this? Because if nitrogen is going to exist in oxidation state anywhere in between -3 and +5, then that means it will show disproportionation. For example, if you take HNO2, in the HNO2, if you see, the oxidation state of nitrogen is +3 here. So when it is +3 here, that means it is in between the lowest and the highest. So once it is between the lowest and the highest, it means it will show disproportionation. So what question they will ask you? They will ask you HNO2 போட்டு ஒரு arrow mark போட்டு அப்படியே கொடுத்துருவாங்க. அப்போ you should write the disproportionation product. Now the problem is, அது +3ல இருந்து +5க்கு போகும்னு தெரிஞ்சிடும். அது நீ ஈஸியாக எழுதலாம். Higher oxidation state +5. லோயர் ஆக்சிடேஷன் ஸ்டேட் அது எதுக்கு போகும், +2க்கு போகுமா, +1 போகுமா, +3 போகுமா, அது நீ கொஞ்சம் ட்ரிக்கியாக ஞாபகம் வச்சுன்னு ஆகணும். அதுக்கு வேறு ஆப்ஷன் இல்லை உனக்கு. ஜென்ரலி அதுக்கு ஒரு க்ளூ நான் வாட் ஐ வில் கிவ் யூ இஸ், when +3 to +2, if you see +3 to +5, you can see 2 increases, okay, and therefore the reduction, this is increase, this is oil, this will be oil, and this will be rig, so generally oil will be less than rig. Oil will be greater than rig. Generally oil will be greater than rig. அதாவது ஒரு எலிமெண்ட் டிஸ்ப்ரப்போர்ஷனேஷன் பண்ணும்போது 2 ஃபேக்டர் ஆக்சிடேஷன் நம்பர் இன்க்ரீஸ் ஆகுது அப்படின்னா ரிக் வந்து 2 விட கம்மியாக தான் இருக்கும், 1 தான் இருக்கும். 0க்கு போகிறது ரேராக இருக்கும். பிகாஸ் 0க்கு எலிமெண்டல் ஸ்டேட்டில் போயிடாது. அது எது கூடயாவது ரியாக்ட் ஆனால் தான் எலிமெண்டல் ஸ்டேட்டுக்கு போகும். தானாக போகிறதுன்றது வந்து ரொம்ப ரேர். அது ஜென்ரலாக போகாது. இட் வில் கோ டு சம் ஆக்சிடேஷன் ஸ்டேட். ஓகே, இது ஒரு ஜென்ரல் க்ளூ, ஞாபகம் வச்சுக்கோ. இதெல்லாம் வந்து டிப்ஸ் அண்ட் ட்ரிக்ஸ் தான். இதை வந்து நீ ரூலாக வச்சுக்க கூடாது. ஸோ that is how we அதனால தான் நான் வந்து I told you in the beginning, you have to remember some of the common oxidation states of the elements. Unfortunately nitrogen வந்து கண்ணா அப்படின்னா நிறைய ஆக்சிடேஷன் ஸ்டேட்ல எக்ஸிஸ்ட் ஆகிறதுனால நீ எந்த காம்பவுண்டை போடுறதுன்றதுல உனக்கு பிரச்சனை இருக்கும், unless you are practiced and thorough with that. Otherwise it will be difficult to remember the various oxidation states. அதே மாதிரி if you take phosphorus எடுத்துட்டே சொன்னேன்னா லோயஸ்ட் அண்ட் ஹையஸ்ட்டுக்கு நடுவில் இருக்காது. யூ கேன் சி தட் லோயஸ்ட் அண்ட் ஹையஸ்ட்டுக்கு நடுவில் இருக்கிறதுனால இட் வில் அண்டர்கோ டிஸ்ப்ரப்போர்ஷனேஷன். ஸோ உனக்கு டெஸ்ட்டில் ஆஃப் இயர்லி குவார்டர்லியில் என்ன கொஸ்டின் கேட்பாங்க, H3PO3 ஏரோ மார்க் போட்டு ட்ரையாங்கிள் போட்டு என்னன்னு கேட்பாங்க. ஸோ நீ அப்படி என்ன கெஸ் பண்ணணும், வெறும் ஒரே ஒரு ரியாக்டன்ட் கொடுத்ததுக்கு ஹீட் பண்ணாங்கன்னு சொன்னாங்கன்னா இட் வில் அண்டர்கோ அதில் இருக்கிற ஆக்சிடேஷன் ஸ்டேட் யூ ஷுட் லுக் அட் இட். Once you look at the oxidation state, if it is in between the lowest and highest, then it will show disproportionation. That means here you can see from +3 to +5, you will have some 2 factor is getting increased, whereas -3 to +3, if you count, it will become 3 more. So இது வந்து generally apply ஆகுதுன்றது வந்து கொஞ்சம் careful வச்சுக்கணும். I am only trying to give you some shortcut, but it doesn't always work. Okay, so I think you need not have to really take up this point, so that you remember by yourself. So this is how the disproportionation of the reactions take place. So this is about the general chemical properties of the elements, oxidation state. Then we will see the next one is more